Hello students, how are you all? Okay, hope you all are fine. So today we are going to discuss about a very interesting topic, that is ionic bonding. Okay, I think in the previous class we have already discussed about the chemical bonding chapter, right? And I have already introduced various types of the three types of chemical bonding. What are they? Can you see? Ah, yes, very good. One is ionic bonding. Then, yes, very good. It is covalent and finally coordinate bonding. Okay. So today we are discussing one out of that, that is ionic bonding. Okay. So ionic bond. Okay. Okay, compounds that are composed of cations and anions are called as ionic compounds. Although they are composed of ions, the ionic compounds are electrically neutral. The electrostatic force that hold these ions together in ionic compound is known as ionic bonds. Okay. Now, why should the atoms combine to form ionic compounds? In forming compounds, atoms tend to gain or lose electrons in order to achieve the electron configuration of a noble gas. This rule is known as octet rule, and we can say that in all the compound formation, we can say that this octet rule is obeyed. Okay, so we have said that the ionic compounds are formed by the combination of cations and anions. So let's see what is cation. Okay. Okay. Cation. When an atom loses an electron, it produces a positively charged atom, or it is known as cation. Okay, the most common cations are those that is produced by the loss of valence electrons from metal atom. And for example, you can take sodium atom. Okay, it is having one electron in the outermost shell. So after losing electron, sodium plus, this is an ion. This is known as cation and plus electron. This is a representation of this cation formation. Okay. Now, the second one, that is about anion. How that is formed. The gain of a negatively charged electron by a neutral atom produces an anion. For example, you can take chlorine atom. Okay, after accepting one electron, it will become Cl minus, chloride ion, and this is known as anion. Okay. Now, let's take an example for this compound formation, and okay. So let's take sodium chloride. Okay. So which are the atoms that combine to form sodium chloride? Yes, Ah, very good. Sodium and the chlorine are the atoms. Okay. So please analyze this. The electronic configuration for the sodium atom, it is 2A1. Okay. And for chlorine it is 2A7. What does this mean? Both are not stable, right? So the easy way for attaining the stability is that one electron from the sodium atom can be transferred to the chlorine atom. So both will attain octet, which can be represented like this. Okay, right? So that the electronic configuration of the sodium ion will become 2A, and that of the chloride ion will become 2,8,8. Okay. So which atom donate the electron? Yes, it is sodium. How many? Yeah, it is 1. Then which atom accepted the electron? Chlorine. How many? Yes, it is 1. So then how are the atoms are called after they get charged? They are known as ions. Sodium, the Na plus is known as a cation, and Cl minus known as anion. So once again, during the formation of sodium chloride, sodium atom donates an electron and gets converted to sodium ion, that is Na+. The positive ions are called cations. Then chlorine accepts an electron to form chloride ion, that is Cl minus, and the negative ion are known as anions. So through this, sodium and chlorine atoms complete an octet in their outermost shell and will attain stability. The oppositely charged ions thus formed are held together by electrostatic force of attraction, and this type of attractive force is known as ionic bond. So that the sodium chloride contains ionic bond. Okay. Now okay. Now let's take another example. That is magnesium oxide, which is represented as, the formula is MgO. Okay. Let's see how this magnesium oxide is formed from magnesium and oxygen. Okay. Magnesium, okay, plus oxygen. The electronic configuration is 2, 8, 2, and for oxygen it is 2, 6. So we know oxygen is not stable, and magnesium is also having excess of 2 electrons. So what is the possibility? Yes, magnesium will transfer 2 electrons to the oxygen atom, so that both will attain stability, that is octet, and that can be represented as Mg2 plus O2 minus. Is this clear? Okay? Yes. Now let's take another example, that is sodium oxide. The formula is Na2O. Okay. So sodium plus oxygen plus sodium. Two sodium atoms are there. Okay. Oxygen, we know the outermost shell contains 6 electrons, and for sodium atoms 1 each. Okay. Here also we can say that, right? Oxygen atom needs 2 more electrons to form octet. So both sodium atoms will donate 1 electron each to the oxygen atom, so that this oxygen atom and also both the sodium atoms will attain stability, so that which can be represented as Na plus O 2 minus Na plus, right? Okay, so now I think you got how to represent this ionic bond formation, right? So similarly, you can explain the formation of sodium chloride and magnesium chloride molecules. So the compounds formed by the ionic bonding are known as ionic compounds. Okay. Now let's move on to the properties of ionic compounds. Okay. So first of all, in case of state, these ionic compounds are found to be solid. Okay, they are solid. Okay. Now, in case of solubility, okay, solubility in water, they are generally found to be soluble in water. So, they are soluble in water. Okay. Okay. Next, in case of electrical conductivity, ionic compounds are found. They conduct electricity in aqueous and molten state. So they conduct electricity in aqueous and molten states. Now, finally, melting point and boiling point. Okay, they generally exhibit or they are having generally high melting and boiling point. Okay, high melting point and boiling point. So these are the properties of ionic compounds. Okay. Now let's move on to the uses of ionic compounds. Okay. One is, it is used in food seasoning. Okay. This is found to be used in food seasoning. Then it can also be used as de-icing bonds. So preservative, it can be used in de-icing roads. Okay. Then it can be used as wood preservative. Wood preservative. It can be used as plant stimulants. It can be used as plant stimulants and also as growth regulators. It can be used as plant stimulants and growth regulators. Okay. Then it is, please note it down, okay? It is used as it can be used as for developing to provide electrolyte solution, for developing electrolytes. Then it can be used for water fluoridation. Then water fluoridation. Please note it down, okay? Water fluoridation, paint pigmentation, paint pigmentation, then for it can be used for fireworks, okay, fireworks. Then finally we can say that the potassium bromide has used in veterinary medicine. Okay, veterinary medicine in as a treatment for the animals with epilepsy, and also it is found to be useful. It is utilized in photographic plates and paper manufacturing. So please note down that also, that is the use of potassium bromide, okay, in veterinary, okay, and also in photographic plates. Photographic plates. Okay. So these are the uses of this ionic compounds. Okay. Have you noted? Okay. Okay. So now when we conclude, ionic compounds are those compounds which are formed by the transference of electrons, right? Then the cations and anions thus formed are held together by electrostatic force of attraction. Then we can say various examples that we have already discussed, that is sodium chloride, then magnesium oxide, sodium oxide, etc. Then we can say ionic compounds are characterized by uh, the solid nature, then solubility in water, and high melting and boiling points, and uh, these compounds are found to be very useful in our daily life. Okay, is this much clear? Uh, that's all about ionic compounds and ionic bonding. I hope that the topic is very clear to you. Okay, so thank you students.